Now we're going to look at using one of our sensors to detect an object. And what we're going to look at is using the Ev3 Ir sensor. If you don't have the IR sensor, you can do this equally with the ultrasonic sensor. So depending on which kit that you purchased, we're just going to use this to detect an object. So when we take a look at this, what we want to do is we want to use the little eyeball looking things. Okay, so this is one of the sensors that we attached, IR or ultrasonic. I'm going to call it IR for the rest of this video just to kind of make it a little bit easier, but if you're using the ultrasound, just know that I'm talking about either sensor. So make sure that we're connected to port 1 of the EV3 brick, and that way we'll all be kind of doing the same thing. And what we want to do is we want to put an object in front of the tracker, and we want to see how we can use the IR sensor to detect it. And what we want to do is we want to use the IR sensor as a true-false reading. And what we're going to do is we're going to program it to have a threshold where we say, if you see an object less than this amount or less than this distance away, I want you to do something. And what we're going to do is we're going to play a high-pitched note. Okay, and then if there's not an object detected, play a low-pitched note. And what's interesting is not only are we going to get a little experience with another block within the programming tool, that being sound, we're going to use these sounds throughout the rest of the course because they're really insightful in terms of letting us know where the program is during its execution. So a lot of times if you set a program up and there's no feedback, what can happen is you download the program and your tracker won't move. And you really have no way of knowing what's going on unless, one, you connect the cable and you use the interface to see where it's stuck in your program loop, or you can do something to one of the sensors in order to get it to respond. So playing a tone is a really handy way to kind of figure out which path it's taking through the decision statement or the switch block, which it's called in the program. And we can use this when we debug our programs, and then we can also, you can take them out at the end if you want, okay? So anyway, the rationale for this is to gain experience setting up the IR sensor, or the ultrasonic sensor, to detect something, and then get additional information about the sound block. So let's go ahead and bring up our LEGO EV3 software, and we come to the main screen here, and what I'm going to do is I'm going to come up and click on this X, or this plus, and that's going to start a project. So you'll see here that I have my tracker and I have the IR sensor connected right here, just like per the building instructions, and I have it connected to port 1. So what we're going to do is I'm going to have a book, and I'm going to have this book be at varying distances, and I'm not even going to move the tracker. I'm just going to have it play a high-pitched tone when it's close and a low-pitched tone when it's far away. And this is just going to show me how to set up this ability to detect an object. Okay, so we can come in here and we can rename our program. So we'll say like detect 1, and you can also save your project as something too. And this is kind of a neat one because we're going to leave the cable connected for this entire thing since there's not any locomotion in here, and it will allow us to view graphically in the interface where the program is executing. So the first thing we want to do is we are going to do this forever. So we're going to loop forever. So go ahead and grab a loop construct. And this is down in the flow control, and we're just going to leave it as an infinite loop. And then what we're going to do is in that flow control, grab the switch block, and remember the switch block is not, it's what the decision construct is. And I drop it in there and it's a little off screen, so I'm going to go ahead and grab the pan tool over here and I'll bring that down, then go ahead and get back into the select tool. And what I'm going to do is I'm going to set up the switch. Okay, so this decision statement. So I'm going to first go to right here and I'm going to select the sensor. So I'm going to tell it that I'm using the infrared sensor, and I can actually do it a couple different ways. I can either do a measure or a compare. We want to do a compare, and we want to compare proximity. And then it's going to give us the option of less than some threshold. So if you look at this, it's got 4 right here. That's actually corresponding to the equality or inequality symbols here. So either equal to, less than, or equal to. So I'll go ahead and I'll just say, to make it simple, I'll leave it at less than. And then here is a number that allows you to enter some sort of distance. So I'm going to enter in 20 there. And these don't necessarily correspond to a unit of measure. It's more of the range of the sensor. So you can dial this in a little bit depending on how far away you're trying to detect an object. And then of equal importance is to make sure that this is connected to port 1. So the switch knows that we connected our IR sensor to port 1. Okay, so if I run this, what will happen is if an object is less than the threshold 20, it will go through this path right here and then repeat. And what I'm going to do is I'm going to plop a sound in there. So go ahead and under action, and you'll see over here to the right, you'll see this sound block. So I bring that up here, and I'm going to drop it here. And then I'm going to set up the sound. Okay, so the first thing is you click right here, and you can either have it play a file, so you can provide a file like an MP3 or a WAV file to have some sort of custom audio, or you can play a tone, or you can play a note. So I'll play a tone, and we're going to play a high-pitched tone when you see something too close, and a low pitch when you don't. So what I'm going to do is I'm going to set this up, and let's do a high-pitched song. Let's do like I don't know, a G, and then I have these settings too. So I've got this duration, and I have volume, and I have this setting right here, which is whether you do to completion or just play once or repeat forever. And I'm going to show you a couple different settings on here and why it affects the sound. But first of all, let's turn the sound way down. So go ahead and turn it to 20, because when it's at 100, it is actually pretty loud, and it kind of distorts the speakers on it. So I got my sound set up, and now what I want to do is I'm going to copy and paste that. So I highlight it, Control C and Control V, and I'm going to drag this down into the path that will be taken if the object is not detected within a threshold of 20. So here I want a low pitch sound, so I'm going to go ahead and we'll just do whatever the lowest pitch is, which is a C. Okay, and I'm going to leave this at exactly the same thing. So at this point I can download and run this. So I'm going to go ahead and I'm going to hit run, and I'm safe to do that because I have no motion in here. So I'll go ahead and run this, and there's a sound playing, and notice that it's a pretty low sound. So now I'm going to bring this up, and then here comes the book, and as it gets closer and closer, you notice that the high-pitched sound. Okay, so it detected it. So we've actually accomplished what we came to accomplish. And what's another important thing about this is look in the GUI. So right now, notice that this path is actually lit up right here. And if I bring the object closer, you notice that it's going through that path. Okay. So this is working, and I want to highlight a few things. First thing I'm going to do is stop this, and the next thing is turn this volume down, because that was really loud and it was only at 20. So I'm going to go ahead and do this 5 and 5, and let's just test it, since testing is really easy when the cable isn't. So that's a little bit better. Notice the click. So how it's going dun, dun, dun. That's because we have this switch setting, or the sound block, set to a duration of 1, and we allow it to complete. So what I could do is, you might think I want to repeat forever, and so if I change that, let me go ahead and stop this. I could change this to repeat forever, so I'm going to go to repeat forever and repeat forever, and I want to see what's going to happen here. And let's go ahead and download this, and let's see the implication of that. Now listen to this. It's completely distorted. And then when I move the book closer, it's a higher pitch noise, but it's still distorted. And what's going on here is that this is going very, very quickly through the loop. So it's basically saying, okay, I'm just going to play this continually, but it goes through really quickly, comes back around, and then it almost like interrupts itself so quickly before it can even get a full cycle of the sound wave out that it just distorts it. So this unlimited is kind of not a really desirable way to do this unless that's the end of unless it's not in an infinite loop. So one way you could do it is go ahead and play once or play to completion, and they're each going to do the same thing if they're in a loop. So if you say play once, it's going to then immediately loop and do it again. Let's go ahead and put it to completion. And now what I want to do is let's take this down as small as it can go. So let's do it to like 0.1, so 1/10 of a second. And let's see what we have here. And what I'm going to do is, no, I'm just going to leave it like that. So I got a high pitch down and then a low pitch down. So go ahead and run it. Now it's moving a lot faster. So we did it. So we have this ability now in order to do the following. We've actually figured out how to use the IR sensor, or ultrasonic sensor, to detect an object within a proximity. So we were able to say, okay, I know that something is within a certain proximity, and I know when it's farther away than the certain proximity, and we use that in a switch or a decision process, a decision construct. And what we did was we introduced this sound block where we said, okay, if I come through here, this is when the object is detected, meaning that this condition, this less than a threshold of 20, was true. And so the check mark means true. And then if it was false, meaning the X, it would then take this path, and this path represented play on a lower pitch term. So that's really all we really wanted to accomplish in this video. And so the next step is, you can notice that you've now got a second very small check, meaning that we're making our way through the sensor module. So the next thing we want to do is kind of look at combining some of the sensors with the object detection with some locomotion, and kind of see if we can have an object cause the EV3 to alter its course, and maybe not only just detect an object but avoid the object. So we'll do that next.